Hey, welcome to the lesson about applying coordinate geometry. How can we use the coordinate geometry to solve problems? Well, by the end of the lesson, you should be able to review the midpoint, slope, and distance formula, and then apply the appropriate formulas to solve certain situations, and to know which formula to use in those situations. Here's a chart with our three formulas that we've learned about: distance formula, midpoint formula, and slope formula. When do we use each one? Well, for distance formula, when the sides are, when we want to determine whether sides are congruent or diagonals are congruent. If they have the same distance between 2 points, then the segments connecting those 2 points have the same length. Midpoint formula, to determine the coordinates of the midpoints of a side and where diagonals bisect each other. So if you have two diagonals and they do indeed intersect at the midpoints of each of those, then that is a specific type of quadrilateral, and you could classify that as a rectangle or as a parallelogram.
And last but not least, you have the slope formula. This, we can take the slope of opposite sides or consecutive sides. If opposite sides are parallel, then you either have a trapezoid, or if they aren't, then maybe you have a kite or other types of quadrilaterals. Also, if consecutive sides are perpendicular, you know that those angles where they intersect are going to be 90 degrees, for example. That could be a good way of telling whether a parallelogram is a rectangle or not. If consecutive sides are perpendicular, then the interior angles will be 90 degrees. Here we have an example of a quadrilateral in the coordinate plane. Just for example, we could find the side length of CB. In order to do that, we're going to use the distance formula. So if we look here, -2, 1, 2, 3, 4, that's C. So C is -2, 4. We want to find the distance from that point to B, which is 2, 1, 2, 1, 2, 3, 4, 5, 6, 2, 6. So I have my two coordinates. I'm going to use the distance formula. D equals the square root of x1 minus x2 squared plus y1 minus y2 squared. So I'm simply going to substitute in for my equation, and let's label our x1, y1, x2, y2. So where x1 is, I'm going to put a -2, so D equals the square root of -2 minus my x2, which is 2, all that squared, plus my y1, which is 4, minus my y2, which is 6, so 4 minus 6 squared. So D equals the square root of -2 minus 2 is -4. -4 squared plus 4 minus 2 is -2 squared. So I'm going to have D equals the square root of 16 plus 4, which is going to be the square root of 20. And that is, well, I could simplify that even more to 2 square root 5. And that is my total distance of CB. Now, if the problem I wanted to find the midpoint of CB, I could easily look here, and you can see that, okay, that looks like the midpoint, 0, 1, 2, 3, 4, 5, so we're going to guess that 0, 5 is the midpoint. But let's use the midpoint formula. We can check our answer algebraically. So the midpoint should be x1 plus x2 all over 2, y1 plus y2 all over 2. And so if I substitute my x1 and my x2 in there, I'm going to get negative 2 plus 2 all over 2. And I plug my y1 and my y2 in, I get 4 plus 6 all over 2. And I'm just going to bring that over here. So negative 2 plus 2 is 0, so I'm going to have 0 over 2. And 4 plus 6 is 10, 10 over 2. If I reduce those fractions, I do indeed get 0.5 for my midpoint. And last but not least, let's find the midpoint of these, the slope of CB. And so our slope is going to be the change in y over the change in x, so y2 minus y1 over x2 minus x1. And we substitute in our y2 is 6, our y1 is 4, our x2 is 2, our y2 is, our x2 is 2, our x1 is negative 2. If I add here, 6 minus 2 is 2. 2 minus a negative 2 is actually 2 plus 2, which is 4. So our slope is 2 over 4, which can reduce to 1 over 2 is our slope. And so for every 1 unit the line goes up, it goes to the right 2. And we can see that here. If we go from point C to the midpoint, it goes up 1 over 2. And then from the midpoint to point B, up 1 over 2. Just a good way to check your algebra. And so our slope of CB is 1/2. Now I could use that information further, find the slope of OE. If those slopes are the same, I know that those opposite sides are parallel. I could also check CO and BE to see if they're perpendicular to CB. If they are, that means these angles would be perpendicular. So there's many ways you can apply the slope formula, midpoint formula, and distance formula to identify and classify quadrilaterals and other polygons as well. So how can we use the coordinate geometry to solve problems? Well, using the appropriate formulas, you can mix and match, and pretty much it's limitless to the information you can find out for quadrilaterals and their sides and their angles. And knowing the properties is also a big help into classifying what types of polygons you're dealing with. So again, make sure you copy these down if you haven't already. Pause the video, get these in your notes. These formulas are very important. You will need them, and you'll want to have them quickly available for upcoming assignments. Make sure you get started on those assignments. If you have any questions, as always, reach out to me. BBIM, email, phone, whatever's easiest for you. And if you can't reach me, make sure you go to Math Cafe. There's always a teacher in there from 9 to 3 willing to help you out. I'm in there Monday, Tuesday, and Wednesday at 11 a.m. And be sure to join us for the next lesson where we will be just reviewing all of the chapter for our upcoming tests on polygons and quadrilaterals.